So previously we had looked at the output from a logistic regression model proposed by Halvarian in relation to HMDA Boston Federal Reserve dataset that was developed by Manel et al. 1996, and then also same analysis is introduced into Stock and Watson. And we now in this video look at the compare the results of the logistic regression and the C-tree model with RandomForest. And random forests are somewhat similar to C-tree, except if we take a definition here from Wikipedia, random forest or random forests, decision forests are an ensemble learning method for classification, regression, and other tasks. Operate by constructing a multitude of decision trees at a training time and outputting the class, that is, the mode of the classes, or mean prediction of the individual trees. So the output, if it were a number, we could take the mean prediction from a whole range of trees, and if it's for a binary variable that we're predicting a 0-1 type output, then it's majority vote. So random decision forests correct for decision trees, habit of overfitting to the training data. Okay, so this is another approach. It's popular and it has some just is a resource we would be keen to utilize. So let's just implement here. We load into the library the RandomForest package, and because it's a random, so part of the approach here is that we take the data set, if you like, and then we randomly sample segments of the data set, cutting different columns out, cutting different rows, and then we resample with replacement, and we use the model to make a prediction. And we do it for one tree, we do it for another tree, and this random sampling, cutting and slicing of the entire data set, then all the different trees are collated into a forest. And then for a binary, if we're predicting a binary variable, then we take a majority vote. So we can, because it is random, we should set a seed so we can reproduce the output. We want to replicate the output, and because it's random, we want the same set of random numbers that can be utilized again and again. So setting seed allows us to go back and replicate our results. So we set the seed at 1, 2, 3, 4, and then like before where we invoke C-tree, now we invoke RandomForest. The variable we want to predict is the I, and we use the entire data set. Okay, so let's run. And then we want to predict using this model, and we have RF predict, and of course if we run that now, we have a set of predictions of yes, no, okay. We also would like to create a confusion matrix, and that object is called rf.confe, and then we'll run, and we can observe the prediction and then the actual. So we predict that here we have 2061 that we predict correctly as getting the mortgage, and we've 94 here who we predict correctly as individuals not getting mortgage, giving the independent variables, and then here we have the error. And if we want to calculate the total error, we sum these two cells here. So that's what we're taking into account. We're adding the 1, 2. So column 1, row 2. Row 1, column 2, and then row 2, column 1. We add those two together. Let's run and examine the output, and we get 225, which is better than C3, but not better than the Logut error. If you recall, the error from the Logut model was also 225 as well. So this RandomForest is useful. It does improve our estimation compared to the C3. Its downside here to some extent is we don't actually see a tree because there's a forest, and we don't get the intuition perhaps that we might have had when we looked at the C3. So the RandomForest doesn't produce an analog to what we had before here. We don't get a C3 output, and that's a bit of a downside, I think, because this, I think, provides us with some intuition what's going on in the background, and it gives us talking points. RandomForest doesn't provide that. It does, however, we can order the variables in order of importance. So we can run importance RF. We can sort those. Then, so if you like, if I run IMP here, you can see it provides us with each of the predictors, and then we can observe which variables are the most important. So it would appear here at first glance that using this mean decreasing accuracy as our main metric, that DMI is the most important here, and then we're probably looking at DIR would appear, and actually it might be difficult to track that, so it makes sense then to maybe sort the order here of, and we're using the third column. So let's run that and look at that, and we can see, okay, DMI. Okay, so DMI is 6612. Right, that's what we have. That's the most important or most relevant variable in terms of accounting for the prediction. Then the debt expense or debt service to income 31. Then HIR. Then loan to value ratio is equal to 21. And you can see its order in descending order. At the bottom here, unemployment, whether the individual is self-employed or not, and then race third from the bottom here. Again, RandomForest and C3 tend to make less evident the fact that race is important here, and would attribute highest levels of importance to these other variables. Now, Halvarian says in his paper, the 2014 paper, that race may be correlated also with these other factors. So by just purely observing the ordering here may not be that revealing, in particular if we are aware that race and, for instance, DIR or credit score or denied mortgage insurance are correlated, are highly correlated. Okay, we could also run the fit here, and that gives us again a confusion matrix. So basically the same type of output as we had before, the 2061 and 94. We're getting the same output, and then an importance plot. And if we look at this mean decreasing accuracy, that's what we've captured here. So the most important variable in the mean decreasing accuracy plot here is denied mortgage insurance, then DIR, then HIR. So these variables are one of the same thing. Okay, so that's RandomForest. Forest is quite a powerful tool, and we can use it for making predictions. So, for instance, here when we ran our prediction from the model using the entire data set that we had, we can use the RandomForest algorithm to make predictions. We can identify the variables that are appear the most significant in order of importance, and the downside is we don't have a C-tree equivalent graphic output, so the RandomForest is a little bit of a black box. Nevertheless, when we looked at the error here, the error was quite low, was 225, which was on par with the logistic regression model. When we are trying to predict something, but we don't quite know how to understand the non-linearities that exist between the inputs or the dependent variables, then RandomForest offers something else. The RandomForest model offers something that perhaps other models don't, like its name implies. So this is from Towards Data Science, and it consists of a large number of individual decision trees that operate as an ensemble. That means putting them together. Each individual tree in the RandomForest spits out a class prediction, and class with the most votes becomes our model's prediction. So we have a kind of a majority voting taking place. The fundamental concept behind RandomForest is a simple but powerful one, the wisdom of crowds. So we slice and dice the data into different rows and columns with replacement in that sampling. And then in data science speak, the reason that the RandomForest model works so well is a large number of relatively uncorrelated models or trees operating as a committee will outperform any of the individual constituents models. Okay, so this is touted generally as one of the key advantages of the RandomForest type design, and it's one that we can use here in RStudio. RStudio has cloud, has available all the packages, and RandomForest Party are the two ones that are identified using Halvarin's R script that he made available in his paper. Okay, so that's RandomForest, and its performance here is comparable to the other models, a bit better than C-tree and on par with the logistic regression. And in terms of identifying what's important or not, it would tend to downplay race as being an important factor, but again, as identified by Halvarin, race may be correlated with other predictors that we have somehow ignored in this process. And so the fact that we downplay race in the analysis may actually be undeserved. And again, in the logistic regression, it was fairly clear that when we looked at that output, race was statistically significant and quite important. Less so in terms of the RandomForest and less so in terms of the C-tree. Okay.